Hey there, Mr. Weaver here, and this is lesson 7 of our Systems of Equations unit. This is the last lesson, and we will be focusing on word problems. After this lesson, you need to be able to write a system of equations from a word problem, and you need to be able to answer questions about the system of equations from context. You'll know you're successful after this lesson if you can write the system of equations from the word problem and answer any questions given in context. So let's jump right into this. We have a couple different formats of word problems to look at, and most of the problems that you are going to see will be one of these formats. So first, before we begin, in this problem, please change the total amount that the resort made from 3,110 to 3,104. This way our totals will come out nicely as if we were really using this in context. A vacation resort offers scuba lessons and snorkeling trips. If a person takes a scuba lesson and goes snorkeling, she will pay $164. On Friday, the resort made $3,104 when 40 people took scuba lessons and 16 people went snorkeling. How much did each cost? Let's start out by defining what each is. So here I'm going to say scuba is X and snorkeling is Y. If you wanted to use different letters to help you know which was which, that's fine. Just make sure you can know. Here, S would not be a good choice since scuba and snorkeling both start with S. So now let's start picking out information from our thing. So a scuba lesson and snorkeling. So that's 1X and 1Y. That total is $164. So my equation, I have X plus Y is 164. One of each is 164. The equation that we just wrote is probably the trickiest one for you to find here. So it doesn't give you numbers, it only says A, meaning 1. So look carefully for this type of information. Sometimes it's not so obvious. For the second one, if we're going in the same order, 40 people took scuba lessons and 16 people went snorkeling, and our total this time was 3,104. So if I put that together, 40 was scuba, 16 was snorkeling, and total 3,104. Now, I have these two equations. They are both in standard form, which sets us up perfectly for elimination. So I'm going to multiply the top one by negative 16. That way my y's will eliminate. I could have also multiplied the top by negative 40, but we chose negative 16. The bottom one doesn't change. Now I can add them together, so I can eliminate the y's. I would get 24x equals 480, divided by 24. X is equal to 20. So, scuba must be equal to $20. Because that's what X was. Now, to figure out my other total, I just plug that back into one of the equations. So I'm going to choose the top one. 20 for scuba plus snorkeling is 164. So Y is 144. Snorkeling must be $144. Okay, so I asked how much each cost. Scuba was 20, snorkeling was 144. Now, realistically, those two numbers would probably be switched where snorkeling was $20 and scuba was $144, but for the problem, it is what it is. Now it's your turn. Pause the video and see if you can figure out how much a Gatorade costs and how much an order of chicken strips cost. Let's check through this. So if we said Gatorade was X and chicken strips was Y, then we can write our equations. Or if you chose to use G for Gatorade and C for chicken, that's fine too. So a Gatorade and an order of chicken strips, so one of each, is $13. At the game on Sunday, they sold 56 chicken strips, 82 Gatorades, and made $832. So 82 was with Gatorades, 56 orders of chicken strips, $832. Again, it's set up perfectly for elimination. So when you're figuring it out, multiply the top equation by either negative 82 or negative 56. Either way, when you go through this, you should have figured out that Gatorade was $4 and chicken strips were $9. Let's look at a different type of problem. So Nathan started with $250 in his bank account and deposits $100 every 2 weeks. William started with $500 in his bank account and deposits $40 per week. After how many weeks will Nathan's total be the same as William's? So Nathan started with $250, deposits $100 every 2 weeks. So our total here is going to be what we want to figure out. That's our Y. And our weeks is going to be what we're trying to use to do that. So our X. So for Nathan had his total was 100 over 2x plus 250. So we can see that he started with 250, that plus 250 at the end, and then our rate of change here is 100 every 2, which is actually 50. So he is depositing $50 each week. William, on the other hand, started with 500 and deposits $40 per week. So his equation would be y equals 40x plus 500. This type of problem is set up perfectly for substitution because both are solved for y. I can take one and substitute it into the other. Here I took the bottom equation and substituted it into the top equation. Now I can go through and solve for x. First, let's subtract 40x from both sides. Then let's subtract 250 from both sides. Finally, dividing by 10, I get x equals 25. So, in this situation, we wanted to know how many weeks will they be the same? Well, since when we're finding our solution, we're finding when they're equal. So our weeks is x, and x is 25. That means they're equal at 25 weeks. Since we've already answered our question, we can kind of just stop here. Had the question asked, what will the total be when they're equal? Then we would need to continue in solving for y. But since this question only asked how many weeks, that was our x value. Once we figured that out, we're good. So weeks was 25. Now it's your turn again. Pause the video, read through the situation, and come up with your equations. Then how long will it take Bella to pass Jasmine? Let's check. So Jasmine drives at a rate of 140 miles every 2 hours, in addition to the 50 miles she already drove. So here, let's say that X is the time that they drove, and Y is the total miles that they drove. So Jasmine's equation would be 140 divided by 2, x plus 50, or y equals 70x plus 50. Bella would be 75 miles per hour at 25 miles, so 75x plus 25. Again, this is set up for substitution, so plug one of them into the other. Here I plugged the first one into the second. Solve through. You should have figured out that x was 5. And in this context, it's asking how long will it take. So 5 what? It's talking about 5 hours because that's how long it took to drive, miles per hour. So 5 hours. Again, if we needed to figure out how many miles that was at, we could plug 5 in, come up with our total, and answer that question. Last type of question. These are some questions where they're almost like little riddles. So the sum of two numbers is 3. One number is 7 less than the other. Find the numbers. So here, let's say that our first number is x and our second number is y. So the sum of two numbers is 3. So if I add them together, my first number and my second number, I get 3. Then it tells me one number is 7 less than the other. So if I subtracted the numbers, I would get 7. If you're not sure how it's set up, try plugging in some random numbers that fit, at least for one of the equations, just to make sure you're on the right track. Now, you might get lucky and it might be the answer, but make sure it tests and works out in both. So now let's find our two numbers. This particular system is set up perfectly for elimination. And in fact, our y's are already opposites of each other. So all we need to do, add them together. I would end up with 2x equals 10 because y got eliminated, which means x is 5. So my first number is 5. Now, to figure out the second number, I can pick either of these equations. I'm going to choose the first one. So if x is 5, then 5 plus something equals 3. So subtract 5 from both sides, y must be equal to -2. So my second number is -2. Please remember, double check in your other equation as well to make sure that it works. So is 5 minus -2 7? Yes. There's that double negative there, which is like adding. So 5 plus 2 is 7. And -2 is 7 less than 5. It all fits. Now it's your turn one last time. Pause the video and see if you can figure out what the two numbers are. Let's check. So first and second number, x and y. Here are our two equations. Now, the first one you probably got, x plus y is 19. The second one, be careful. It says one number is 9 more than the other. That is still a subtraction problem because let's say you had 1 and 10. One of those numbers is 9 more, but in order to figure out that 9 more, you still had to subtract. So just because it said more than doesn't make it a plus. It's still x minus y. Then adding them, you should have got x equals 5. And plugging it back in, y was equal to 14. So your two numbers were 5 and 14. In this lesson, we learned about different formats of word problems. There are two formats you're generally going to see, and depending on which format it is, that'll really tell you how the problem should be solved. So the first type you might see is slope-intercept form, y equals mx plus b, where there's a rate and a start value. Generally, if we see slope-intercept form, it's wanting you to solve it by substitution. The other equation type we're generally going to see in word problems is standard form, which is ax plus by equals c. Here we're going to be given two rates, so maybe two prices of things, and a total. If standard form is given, or both things are in standard form, elimination is probably the way you should go. Now, more often than not, both of your equations will be the same format as we saw in all of our problems, but that doesn't mean they have to be, so please double check and make sure that the equation you write fits the context of the problem. Okay, read carefully, look for keywords so you can help figure out what's happening. And don't forget, you can always double check all of your solutions through graphing using Desmos to make sure you are doing things correctly. So after this lesson, do you now know how to write your equations from context? And can you answer any questions that are given from context? If you're not sure, go back and watch specific types of problems that fit the format that you need. And that's all there is for Lesson 7 on Systems of Equations word problems.